Hello friends, today we will take remaining problems on analytic function. In last video we already covered 6 to 7 problems. So I think problem number 8, this one is remaining, that is show that analytic function with constant amplitude is constant. So problem is show that analytic function with constant amplitude is constant. Analytic function with constant amplitude is constant. So here we will start problem number 8 solution. So our question is analytic function given. I mean, suppose if we take f of z is equal to u plus iv is analytic function. Okay, and our question is show that analytic function with constant amplitude now is constant. Okay, with constant amplitude is constant. So if we take f of z is equal to u plus iv its analytic function, then how we write its amplitude? So amplitude of f of z can be written as tan inverse of v by u. Our question is with constant amplitude, means this is constant given. Amplitude of f of z is constant, that is say c. This is given in problem. Okay, so means analytic function with constant amplitude. Constant amplitude means tan inverse of v by u is equal to c. With constant amplitude is constant. So we have to show that, to show f of z is constant. Okay, is by taking constant amplitude of analytic function, we have to show that f of z is constant. Now how we show f of z is constant? Since tan inverse of v by u is equal to c, so using this we can write v by u is equal to tan c. Okay, and f of z, when we get f of z is constant if u is constant and v is constant. Okay, so here v by u is equal to tan c. So if you take derivative of this with respect to x, okay, so differentiate partially with respect to x and y both. So how we find derivative of v by u? Using u upon v rule. U as it is derivative of v is dabba v by dabba x minus v as it is derivative of u is dabba u by dabba x divided by u square is equal to derivative of tan c is 0 because tan c is constant. So this can be written as u into dabba v by dabba x minus v into dabba u by dabba x equal to 0. This is equation 1. Similarly, if we take derivative with respect to y, then how we write? Only replace x by y. So u into dabba v by dabba y minus v into dabba u by dabba y equal to 0. So we have to solve these two equations 1 and 2. But here independent variable x, say here y, so we have to change this y in terms of x. And how we change? Using CR equation, because given that f of z is analytic, and if f of z is analytic, then CR equations are satisfied. So by CR equations, so we have to use a CR equation in polar form. First CR equation is dabba u by dabba x is equal to dabba v by dabba y, and second CR equation is dabba u by dabba y is equal to minus dabba v by dabba x. So here what is the value of dabba v by dabba y? We want in terms of x. So dabba v by dabba y is dabba u by dabba x. So put here, therefore u into dabba u by dabba x minus v into the value of dabba u by dabba y is minus dabba v by dabba x. So minus minus plus dabba v by dabba x equal to 0. This is equation 2. And we have to solve 1 and 2. From equation 1 and 2, try to find dabba u by dabba x and dabba v by dabba x. So in equation 1, coefficient of dabba u by dabba x is v. In equation 2, coefficient of dabba u by dabba x is u. So equation 1 multiplied by u plus equation 2 multiplied by v. Okay, means we have to cancel first dabba u by dabba x. If we cancel dabba u by dabba x, then we get the value of dabba v by dabba x. So how we cancel? If you multiply equation 1 by u, then equation 1 becomes u into u is u square dabba u by dabba x minus uv dabba square dabba u by dabba x equal to 0. Okay, and plus if you multiply equation 2 by v, then this becomes uv dabba u by dabba x plus v square dabba v by dabba x equal to 0, and we have to take addition of this. And if we take addition, then this uv dabba u by dabba x get cancelled. So u square dabba u by dabba x plus v square dabba u by dabba v by this is v square dabba v by dabba x. Here dabba u by dabba x. This is not dabba u, this is v. Because if you multiply here by u, then dabba v by dabba x is there. So if we take addition, this dabba v by dabba x we can take common, and if we take dabba v by dabba x common, then in bracket u square plus v square is there into dabba v by dabba x equal to 0. But u square plus v square is not equal to 0, since u square plus v square is not equal to 0. Why u square plus v square is not equal to 0? Because this is the modulus of f of z. Okay, and therefore dabba v by dabba x equal to 0. And if dabba v by dabba x equal to 0, and if we take integration of this, we want v. If we take integration of this, then we get v is equal to c1. Integration of 0 is 0 plus constant of integration is c1. Now put the value of dabba v by dabba x in equation 1 or 2. If you put in 1, say, or if you put in 2, put in 2. Okay, then equation 2 becomes here u into dabba u by dabba x plus dabba v by dabba x equal to 0. But u is not equal to 0, so dabba u by dabba x equal to 0. If dabba u by dabba x equal to 0, then if we take integration, we get u is equal to integration of 0 is 0 plus constant of integration takes c2 here. So u is equal to c2, v is equal to c1, and therefore what is our question? We have to show that f of z is constant, and therefore f of z is equal to, what is f of z? F of z is equal to u plus iv. This is our given function, and value of u is c2 plus I into v is c1. So f of z is constant. This shows that analytic function with constant module amplitude is constant. Now next question is same. That is problem number 9. Show that analytic function with constant modulus is constant. So how we prove this? We will take same. Suppose here f of z is equal to u plus iv is analytic function. So we have to show that constant modulus is constant, means take modulus of f of z, and modulus of f of z is under root of u square plus v square. This is given as c. Okay, if we take square of both sides, then we get u square plus v square is equal to c. So you try this. Take derivative of this equation with respect to x first, then y. Use CR equation, try to find dabba u by dabba x, dabba v by dabba x. Means if we get that 0, then we get u equal to constant, v equal to constant, and from that we can say that f of z is also constant. Okay, and last problem on this topic is if f of z is an analytic function and v square is equal to u, then show that f of z is constant. Problem A, if f of z is an analytic function, if f of z is an analytic function and v square equal to u, then show that f of z is constant. Okay, so how we prove this? Now here, if we take suppose f of z is equal to u plus iv is analytic function. Okay, is analytic function, and in problem again given that v square is equal to u. Okay, v square is equal to, this is given in problem, and question A, to show f of z is constant. So how we prove this f of z is constant? For the same as last problem, we have to show that u and v are constant. So since v square is equal to u. If you take f of z equal to u plus iv, then this u and v are functions of x and y. So differentiate partially with respect to x and y. Okay, so derivative of v square we can write 2v into dabba v by dabba x is equal to dabba u by dabba x, and derivative of v square with respect to y is, that is derivative of v square is 2v into derivative of v with respect to y is dabba v by dabba y is equal to dabba u by dabba x. Okay, so using first equation we can write, if you write this term here, dabba u by dabba x minus 2v dabba v by dabba x equal to 0, and second equation is same, this term write in RHS, this becomes dabba u by dabba x minus 2v into dabba v by dabba y equal to 0. So from these two equations we have to find either the dabba u by dabba x and dabba v by dabba x. So how we find this? Okay, using given that f of z is analytic, in f of z is analytic, then CR equations are satisfied. So we have to change only this here, y present a, we want x. So by CR equation we know that, by CR equation we know that dabba u by dabba x is equal to dabba v by dabba y. Dabba u by dabba x is equal to dabba v by dabba y. Okay, so here dabba u by dabba x, not x here, dabba u by dabba y, we have to take derivative with respect to y. So this is dabba u by dabba y. So dabba u by dabba y is equal to, and dabba u by dabba y is equal to minus dabba v by dabba x. If we put in second equation, okay, this is first, and second equation में the dabba u by dabba y की वैल्यू minus dabba v by dabba x पुट की, minus dabba v by dabba x minus 2v into dabba v by dabba y is dabba u by dabba x equal to 0. This is equation 2. And now to solve equation 1 and 2, we will write again these two equations. First one is say dabba u by dabba x minus 2v dabba v by dabba x equal to 0, and second equation is minus dabba v by dabba x minus 2v into dabba u by dabba x equal to 0. Okay, so how to solve these two equations? So if we multiply here, coefficient of dabba u by dabba x is minus 2v and here 1, so multiply this by 2v and this by 1, and then rewrite these equations again. If you multiply here by 2v, then this becomes 2v dabba u by dabba x minus 4v square dabba v by dabba x equal to 0, and here by 1, then minus dabba v by dabba x minus 2v dabba u by dabba x equal to 0. Okay, take addition of these two equations. If you take addition here, this 2v dabba v by dabba u by dabba x minus 2v dabba u by dabba x get cancelled, and here this dabba v by dabba x common है. So we can write here minus 4v square minus 4v square into dabba v by dabba x minus dabba v by dabba x equal to 0. So if you take dabba v by dabba x common, also take minus sign common, 4v square plus 1 into dabba v by dabba x equal to 0, means this implies dabba v by dabba x equal to 0. Okay, and put the value of dabba v by dabba x in any one equation, either put in 1 or 2. If you put in 1, say put in 1, so equation 1 becomes, equation 1 is this, and here if you put dabba v by dabba x equal to 0, then we get dabba u by dabba x is also 0. And if you take integration here, okay, so integration of dabba u by dabba x is u, integration of 0 is 0 plus constant of integration c1, so u is equal to c1, And same if you take here integration, then integration of dabba v by dabba x is v is equal to constant of integration c2. So we get u is equal to c1, v is equal to c2. Okay, so what is f of z then? And therefore f of z is equal to u plus iv, that is equal to c1 plus ic2. This shows that f of z is constants. In next video we will start bilinear transformation and conformation transformation. Thank you.